GeopByte.
Hello friends, welcome to the GeopByte. In this video, let us discuss the problems which were given in the previous Ecet exam papers for the topic physics. You know, in the Ecet, physics weightage is 25 marks. Among the 25 marks, you can expect 2 marks from the very first topic called units and dimensions. Therefore, I can write the weightage of the first two course, that is units and dimensions, is 2 marks. Dear friends, since all these problems I collected from the previous exams, therefore each and every problem is equally important. After listening all these problems, you practice once again. If you find any difficulty while you are practicing, you please send all your doubts to the GeoByte. Definitely, I will answer all your questions within 24 hours. Look at the very first problem. Look at the very first problem. If m is the mass of a drop of radius r, it is given that m equal to mass. Generally, mass is measured in kgs and r is the radius. R equal to radius. Radius is generally measured in meters. Then mg by pi r has the dimensional formula as that of. Here quantity given is mg by pi r. Here g be the acceleration due to gravity or gravity constant, it is in meter per second square. Then mg by pi r is m is in kg, g meter per second square divided by pi has no units, r is in meters. This meter cancelled. Finally it is in kg per second square. So mg by pi r equal to mg by pi r is in kg per cm square. Now let us take the options. The very first option is surface tension. Look at the surface tension. Surface tension denoted by sigma, it is equal to force per unit length. Force per unit length. As you know, force F equal to ma. M is the mass, it is in kg. A is the acceleration, meter per second square, and length is in meters. Length, depth, breadth, diameter, these are all in meters. So it is equal to force unit is kg meter per second square multiplied by meter. This meter cancelled. Finally its units is kg per second square. Look at the units of the surface tension. Units of the surface tension is kg per second square, whereas mg by pi r is also in kg per second square. Therefore, the mg by pi r is having the dimensional formula as that of the surface tension. Therefore, you can select the very first option is absolutely correct. I hope all of you clearly understood. Let us take the second problem. Look at the second problem. If C is the capacity and V is the potential across the condenser, V be the potential across the condenser, then The dimensional representation for half CV square is, it is like this. Let us the given quantity is x equal to half into C into V square. Here C be the capacity. C equal to capacity. That capacity you can write as Q by V. So x equal to half into Q by V into V square. 1V is cancelled. Finally it is half into Q into V. Q into V, it is equal to half into Q dimensional formula IT, V dimensional formula M L square T power minus 3 into I inverse. This is the dimensional formula. Now you simplify it. This I inverse cancelled, 1t is cancelled. Finally it is M L square T power minus 2. So this is the dimensional formula for the given quantity M L square T power minus 2. Look at the options. The very first option is absolutely correct. I hope you clearly understood. Let us go for the next problem. Look at the third problem. The product of pressure and volume has the same unit as, product of pressure and volume. Let that quantity is equal to x. Pressure is in Newton per meter square, volume is in meter cube. So it is equal to Newton meter square is cancelled. Newton meter is also written as joule. So joule is the unit of energy. Now come to the temperature. No, temperature has in Kelvin. Force is in, temperature is in Kelvin. The force is in newtons. Work is in joules. Work unit is joule. Power unit is watts. Joule per second. Therefore, the product of pressure and volume is the unit same as that of the work. Therefore, option 3 is absolutely correct. I hope all of you understood. Let us move to the next problem. Look at the next problem. The SI unit of moment of inertia is, dear friends, generally moment of inertia denoted by I equal to product of m k square. Here m is the mass, where m equal to mass, which is in kg, k equal to radius of gyration. It's a distance. Radius of gyration means a distance. It is in meter. Therefore, moment of inertia I equal to mk square. M unit is kg and k unit is meter, kg meter square. So moment of inertia SI unit is kg meter square. Look at the options. Kg per meter square. No, the first option is not correct. Look at the second one. Kg meter square. Absolutely correct. Therefore, second option is absolutely correct. Dear friends, very simple problem. Very simple problems are asking from the units and dimensions. You can easily grab these 2 marks. Look at the next problem. Look at the fifth problem. Electrical conductance has the unit of. Dear friends, electrical conductance is the reciprocal of electrical resistance. electrical resistance. Electrical resistance has the unit ohm, OHM. Since the electrical conductance is the reciprocal of electrical resistance, therefore electrical conductance unit is reciprocal of the ohm. Therefore it is generally pronounced with the reverse direction. Therefore electrical conductance. Since electrical conductance is the reciprocal of electrical resistance, therefore the unit of electrical conductance is reciprocal of the unit of electrical resistance. That's why it is generally pronounced as reverse direction, MHO, mo. So therefore the very first option itself is absolutely correct. I hope you clearly understood. Let us take the next problem. Look at the next problem. The dimensions of the quantities is one of the following pairs are same. Look at the very first one. Torque and work. Torque and work. As you know, torque T equal to force multiplied by perpendicular distance. Perpendicular distance. Here the force unit is Newton, distance is in meter. Newton meter is also equal to joule. 1 Newton meter equal to 1 joule. Come to the work. Work also equal to force multiplied by distance travelled by the body. Distance travelled by the body. Force is in Newton, distance is in meter. Newton meter is also equal to joule. Therefore, the torque and work both are maintaining the same dimensions or same units. Therefore, the very first option itself is absolutely correct. I hope all of you got it. Let us take the next problem. Look at the next problem. The force F, velocity V, and time t are taken as fundamental quantities. Find the dimensional formula of energy. You are asked to decide the dimensional formula of energy. As you know, energy equal to energy is in joule. Joule I can write like this: force multiplied by distance. This is the basic definition for work. Work is also coming under a kind of energy. So anyhow, force is in Newton, distance is in meter. Therefore, unit of energy is joule. Unit of energy is joule. Okay. 1 minute. Now, come to our problem. Force is F. Distance, let it be L. Distance is L. But you know, here it is given in terms of velocity and time. Velocity V equal to distance by time. From this, distance or displacement equal to product of velocity and time. So it can be written as force multiplied by L equal to V into T. V into T. So it can be written as F power 1, V power 1, T power 1. So this is the dimensional formula for the energy. Look at the options. Look at the option 4. Fourth option is absolutely correct. Fourth option is absolutely correct. I hope all of you understood. These are all very, very important and easy problems. Look at the next problem. Look at the 8th problem. The dimensional formula of capacitance in terms of M, L, T and I. So for the capacitance, the dimensional formula is M inverse L power minus 2 T power 2 and I power 1 minute and I power 2. So this is the dimensional formula for capacitance. You remember this formula, dimensional formula. More frequently, the dimensional formula for capacitance is asking. Look at the options. The first option is not correct. Second option also not correct. Third option also not correct. Look at the fourth option. M inverse L power minus 2 T square T power 2 I power 2. Therefore, fourth statement or fourth option is absolutely correct. Let us take the next one. Look at the ninth one. Which of the following is SI unit of energy? You know, SI unit of energy is Newton meter or joule. Joule is the unit of energy in SI system. Therefore, the very first option itself is absolutely correct. Look at the last problem. Look at the last problem. The fundamental formula of physical quantity torque is represented by, dear friends, torque means torque T equal to force multiplied by perpendicular distance. Force multiplied by perpendicular distance. Indirectly, force multiplied by distance. Force multiplied by distance or perpendicular distance. You know, force F equal to MA. M capital M L by T square. So it is equal to M L. Of course, it can be written like this: M L T power minus 2 into distance is L. It is equal to M L square T power minus 2. So this is the dimensional formula for torque. M L square L power 2 T power minus 2. Look at the first option. First option is not correct. It is in the form of M square. M square is not correct. It is just M L power 2 T power minus 2. M L power 2 T power minus 2. Therefore, the second option is absolutely your correct answer. I hope all of you clearly understood. Dear friends, with this problem, I am concluding this video. In the next video, I will discuss some more important problems for the same topic called units and dimensions. You please go through all these problems once again, because units and dimensions is the very easy and important topic. You can easily get the 2 marks from the units and dimensions. Anyhow, thank you for watching. Please subscribe our channel called GeopByte. Once again, thank you very much. Have a great day.
GeopByte.